All right. So what we're going to do in this section, and hopefully no interruptions, sorry about the section 6.1, but what we're going to do in this section is 6.2 technically is the graphs of all of the other trig functions. Recall that we have a total of 6 trig functions. For our purposes, I'm only going to be honing in on the tangent graph. I want you to please look and read through the section in 6.2 so that you get a general idea of what your graph of your secant, cosecant, and cotangent are. But for our purposes, what we're going to be doing is honing in on the tangent function. Okay. So recall we can discuss our unit circle, and we know that our tangent, we can think of in a couple of different ways. We know that the tangent of theta is the sine over the cosine, or we can think of it as y over x. Okay. So there's some issues that come up here. Okay. One thing that I want to mention here is as follows. First off, my tangent is going to be positive in my first quadrant, and it's going to be negative in my second quadrant, positive in my third, and negative in my fourth. Notice if both x and y are positive, positive divided by positive is positive. If both, like in my third quadrant, my x and y are negative, a negative divided by a negative is positive, etc. Okay, so that's the first thing that I want you to note. The second thing that I want you to note is that funkier things happen here. Okay, the tangent is actually undefined at various places. Notice our sine and our cosine had our radius in our denominators, and our radius was never equal to 0. But here we do have to, quote unquote, worry about dividing by 0 because our tangent is going to be undefined wherever x is equal to 0. Well, on our unit circle, where is our x value equal to 0? It's equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2. Okay, so notice 3 pi over 2, 5 pi over 2, 7 pi over 2. It's all odd multiples of that. Okay, so what happens when you have it undefined? You have vertical asymptotes. Okay, this is really, really fun. So, okay, this goes back to our rational functions here. What we're going to have is we're going to have a vertical asymptote at each of those values. In other words, as we approach pi over 2, 3 pi over 2, 5 pi over 2, etc., our function is either going to shoot up to positive infinity or shoot down to negative infinity. Okay. So I know that the tangent of 0, it's 0 over 1 is 0. I know when I'm at pi over 2, it's undefined. When I'm at pi, again, it's y over x, 0 over negative 1 is 0. When I'm at 3 pi over 2, I've got myself another vertical asymptote, and then 2 pi 0. And then we can do the same in our negative direction. Got pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, etc. Okay, so the question is, as I approach each of my vertical asymptotes, is my function going to shoot up to positive infinity or shoot down to negative infinity? Well, I know that, for example, pi over 4, the tangent of pi over 4 is at 1. And since we don't have any other intercepts here, this is going to shoot up to positive infinity. Okay, let's just continue on this guy here. I know at negative pi over 4, it's negative here, -1. And what we're going to see is as follows. Notice between pi over 2 and pi, my tangent is negative. Between pi over 2 and pi, my tangent is negative. And this is what our graph is going to keep looking like. Isn't that so cool? So I want you to note a couple of things. With our tangent function, our period is pi. It's not pi over 2. Okay. Our domain, notice we now have values that we have to exclude. Our theta cannot be equal to pi over 2 plus k pi. Okay, we're talking all odd multiples of pi over 2. Notice our range goes from negative infinity to positive infinity. Okay, and finally, I want you to note that this is an odd function. In other words, the tangent of negative theta is negative the tangent of theta, right? It reflects about my origin. So in sum, and then I'm going to just go through a few examples. Okay, this is a tiny section. If you have this, what I want you to note is that your amplitude is A. I guess we could rewrite it another way. My amplitude is A. Now my period is 2 pi over this value. And right here, I would shift it right p units. And here I would shift it right m over k units. Again, because here it's not factored out. Oh, excuse me. I'm really sorry, and I'm glad I noticed that. My period, so do as I say, not as I do. My period is pi over k, not 2 pi over k. All right, sorry about that. All right, so what I want us to do is just go through a couple of examples. Nothing too heavy here. Really what matters to me is that you have the general feel for your tangent function. Most important things really are that you have vertical asymptotes and that your period is pi and your range are all reals. Okay. If I have, for example, f of x is equal to 2 times the tangent of 4x minus 32. All I want to know here is what is my period and what is my horizontal shift. All right, well, my period is pi over the number in front of my variable. So here my period is pi over 4. Notice I don't have this factored out. So negative 32 over 4 is 8, and I'm subtracting, so it's to the right. Okay. Here's another one, just making use of the fact that it's an odd function. It says if the tangent of x is negative 1.5, find the tangent of negative x. Well, since this is an odd function, we know that the tangent of negative x is negative tangent of x. So negative 1.5 is simply 1.5. Okay, nothing tricky here. We're just using the idea of it being an odd function. All right. And finally, what if I want us to graph this tangent function? All right. Well, notice there's no shift. What I'm really wanting to do here is just make sure that we're cool with the idea of the period. So my period is pi over 2, which is pi divided by pi over 2 times 2 over pi. So now my period is 2. So I can go out 1 and -1. And this is essentially all you need to be able to do. Okay, so here's 2 and then 3. And there we go. All right. I hope that this was helpful and it was finally a decently length video. Okay, thanks.